presentation up. So, look, thank you very much, Mark, and thanks everyone for coming along. I'm sorry that I couldn't actually make it in person because I was really looking forward to that, but I really appreciate the fact that you're able to come on to a Zoom presentation. As Mark said, I'm an experimental archaeologist. My area of specialisation is buildings. I am the project archaeologist at Butser Ancient Farm. And what that really means is that I work with colleagues, particularly my wonderful colleague, Trevor Creighton, to come up with ideas, in some cases funding, and then develop those into buildings. So we look for archaeology. Quite often we're targeting archaeology. We might know that we need to build a Neolithic house, or we need to build a Bronze Age house, or whatever it might be. So I work with colleagues to sort of identify possible buildings or possible archaeology, and then try and translate that into a meaningful structure. And tonight what I want to do is go through 3 buildings that we built over the last 3 years, one of which is Neolithic, the other is Bronze Age, and the other is Anglo-Saxon. And in doing that, I think I can take you through my job description, really, where we can look a little bit at the archaeology, we can look a little bit at why we built it the way we did, and then look at the finished product. For a little bit of background, Butser Ancient Farm is actually, well, turns 51 this year. So we've been an experimental site specialising in archaeological buildings, experimental buildings, since 1972. We were founded, not on the site we're on now, at a nearby site on Butser Hill, which is a really prominent landmark if you're heading in on the A3M to Portsmouth. So we didn't invent experimental archaeology, but our founding director, Peter Reynolds, was really key to developing experimental archaeology as a science, you might say. And he kicked off in 1972 building mostly Iron Age roundhouses. Now we are firmly into all of the periods of, well, prehistory all the way back to the Neolithic in Britain. We work, as we know, as an experimental site, but we also work to deliver education. So we have about 35,000 school children who visit us each year. We have about 20,000 members of the general public who can be just visitors from Britain and elsewhere. They are sometimes university students and so on. That is what we would once have called in a normal year. We're starting to get good numbers back up post-COVID. I'm not sure that we're there yet, but we're getting there, which is better than a lot of institutions. And we work from Neolithic, Bronze Age, Iron Age, Romano-British and Anglo-Saxon. So I'm going to sort of slide us through that chronology tonight. And I want to start with this building. It was built in 2019 and 2020, and it's a Neolithic structure. We call it the Horton House. Now, I'm hoping you can't see a little drop-down menu I've got on my screen here. And I think there's a little bit of a delay between my pressing the change button on these slides and the slide coming up on your screen. So I'm going to try and delay my speaking for a little bit, and I hope that all makes sense and syncs well. So what we are dealing with here was really interesting archaeology. We needed a Neolithic building. Our previous building had basically almost fallen down due to strong winds. And we were lucky enough to find some recently excavated archaeology, so 2012, that was excavated at Horton, a large gravel quarry near Heathrow Airport. And it was excavated by Wessex Archaeology. And what you can see on the screen here, and I'll get my little pointer up. I think I need a different pointer here. Pointer options, let's go laser pointer. So what you can see here is a partly excavated trench. And that trench was the foundations for a very large building. It was a very interesting building. One of the things that was interesting about it was its size. So in the Neolithic in Britain, tend to have fairly small buildings with a few exceptions. This building is very large. It's 15 metres long by around about 7 metres wide on average. The other peculiarity of it is it has very few post holes. Now, post holes are sort of the stock in trade of the experimental builder, because post holes tell you a lot about a structure. They tell you whether it's rectangular, whether it's round, and they also give you a lot of hints about how the roof stands up. And this building doesn't actually do that, which makes it really quite a fascinating and a very challenging building to build. So what we're looking at is a building that's roughly the size of a medieval building. As I said, 15 metres by 7 metres. It has very few post holes, as I said. So this is a sketch of the ground plan here. And you can see there's an entrance on the side, post holes identified at these points here and here, and otherwise nothing. So what we've got is a sort of something the size of a fairly sizable medieval church that isn't held up by posts. It appears to be somehow self-supported by its walls. And that's really very challenging from a structural point of view. There are only a few large Neolithic buildings in Britain. There are about 6 that I know of. No, probably about 8. 2 of them are on this site. 2 of them conform fairly closely to this ground plan. The other one is somewhat smaller than this. And there were 2 other accompanying buildings. But this particular type of building is a bit of a puzzle. You do get very large Neolithic buildings in Europe, and some of them are sort of 70 feet long. So, you know, sort of 25, 30 metres long, but they've got lots and lots of posts in them. My colleague Claire Walton called them a forest of posts. So it's very easy to understand how they stand up. You can see that you've just got all of these posts kind of jacking up your roof. We don't have that in this building, which makes it very peculiar. So we built this, and I'll detail the reason that we got to this, this A-frame structure. But significantly, what you'll see here is where we've put posts into the ground is where the posts were identified in the original excavation. I should say where we put vertical posts into the ground is where the post holes were identified in the, I'll just go back, where the post holes were identified in the original excavation. So one of the things that really informs the way we build a building beyond the archaeology, given that the archaeology is very scant, especially in the Neolithic, but most of the buildings we deal with, other than the Romano-British buildings, tend to be built of wood. So you get very little information about the structure beyond the shape, and hopefully some structural engineering indications in the form of post holes. Well, again, we don't have many post holes in that building. So it was a particular puzzle, wonderful puzzle. Our building has a roof that weighs about 10 tonnes. And you can see from my illustration here, if I make this as a kind of conventional building, what you have with a 10-tonne roof is a roof that wants to spread the walls apart. It wants to push the walls down just by its weight. So what you have to do is tie those walls together. So these lower arrows, they're actually the counteracting force, if you like. So what you would do in a medieval building or a lot of modern buildings is you would create a roof truss. And the roof truss would be a triangle up here, and it would have a very well anchored beam that goes across the middle. If you look up in medieval buildings, and we'll see some examples of this later on in the presentation, you'll see rather elaborate jointing that does this job, that actually anchors the roof together. If you don't have quite significant joints, the roof will actually cause the building to collapse one way or the other, or the wind will help you along your way. So what happens is not only do you get these roof loads that want to push your building apart. In fact, if you go along to a lot of even stone buildings, say medieval or post-medieval stone buildings, you'll very often see anchor bolts through the walls where a steel rod has been put in to tie the walls back together because that roof is pushing the walls apart. So you can imagine the problems with a timber building. You'll notice here is our lateral loading. This is from the roof, but also you get this longitudinal loading, and you'll get this twisting force. So if the building gets blown on by a heavy wind, then you can get all sorts of twisting forces. And we had an earlier building here. This is the building that we needed to replace. This is called the Llandegai building from Wales. This building suffered structural compromise as a result of exactly all of those forces. You can see here, even within a year, these props were not noted in the archaeology. They were there basically because the building had already started to fall. Now, one of the things we wanted to do was use as much Neolithic technology as we possibly could. And the great thing is that there is evidence for Neolithic carpentry. So this is a well in Germany, and it's remarkably well preserved and remarkably well made. So we were able to get the information from this. And the slide up here is one of those wonderful 3D photograms. So you can see this is actually a well lining, and this is the way it's put together. Some people might be familiar with the little kind of plastic building blocks that you get as children. So these little sections here are kind of slotted over one another, and this is a peg. So they're slotted and pegged. This is really rather beautifully made, beautifully dressed timber, beautifully cut holes, well-drilled holes, and pegs to anchor them all together. So we were able to get some information about Neolithic carpentry that we can be quite certain of. So we knew that we could at least do this level of carpentry. To be honest, we can't do this level of carpentry. It's beyond us with our capacity, because what we wanted to do was use Neolithic toolkit. Now, to be honest, we didn't use a Neolithic toolkit for the entire building, but for one of the main structural members, we only used stone axes, bone drills, and wooden hammers. We wanted to be able to prove that we could, with our fairly limited skill set, as I said, we could not possibly do something as well as that Neolithic well from Germany with our skills, but we wanted to be able to do with our skills and the tools that we know were at hand to be able to build the main structural component. For reasons of time management, we then switched to modern tools, but in fact, they were all hand tools. Now, this building is quite simple. You can see that we have these vertical posts here. As I mentioned, they're anchored into the ground where the original excavators identified posts, or at least suspected posts. And on top of that, we put a very simple A-frame. In some of these posts here, we've drilled holes and we've used pegs to anchor them, just as was done in that German Neolithic well. And we've used these beams across here on which to rest these sloping A-frames. The other thing to say about this is the original site was in a wetland. So we know that they had access to reeds, and that informed our decision to make a reed thatch. We know that reed thatch needs to have a roof pitch of about 45 to 50 degrees. And so that also informed our structural engineering. So we're taking as much information as we can from known archaeology, from the archaeology of the site, and also from what we know about the biology and the biota of the site to create a building. You can see the pegging on this post, and you can see the rest of it is just lashed together. It's built of Scots pine and hazel. We use commercially sourced twine, as you can see there, but we've also done experiments to prove that that sort of twine can be made with reeds, with a number of things. Whether they would use as much as we did, we can't say, but we wanted to use a very simple structural form that we could complete without cheating. So there are no hidden nails, no hidden bolts. So here's back to our archaeological footprint. You can see this sort of lozenge shape, as I'll describe it, with two little dividing walls. These are particularly interesting. However, we've put an A-frame up and we have anchored some of these structural members, these roof rafters. They've actually gone into the ground. So 5 of those have gone into the ground. And it has to be said, there is no archaeological evidence for slanting posts in the ground. Lots of archaeological evidence for timber, but the timber would appear to be horizontally placed in the ground. And I'll move on to why we did and didn't do that in a moment. But what we've done is we've devised a structure that we believe will stand up. Well, it does stand up and not be structurally compromised. A structure that sort of answers most of the archaeological puzzles, with that caveat that there is no direct evidence for these slanting posts. And these posts, the 5 major structural posts, a lot of these rafters just sit there. They're just to take the thatch, but 5 equally spaced rafters along the length of the building are anchored into the ground, so they slope into the ground. So they're our structure. And in place of a tie beam, as we discussed on that roof before, the earth ties it together, which stops the building from spreading. We didn't use any machines. So while we made some sort of, I suppose you might say, a compromise on the archaeology, we didn't make a compromise in the way that we constructed it. So no machines, everything was raised by hand and tied by hand. It was very interesting climbing up on that 5-metre high roof, tying all of that stuff. So to the extent that we possibly could, we've tied what we can do with our tools, what we can do with our hands, and what we can do with the archaeology as closely as possible to get the finished result. Now, there's an alternative, and this was the alternative offered by Wessex Archaeology, who were the excavators. So experimental building is always a series of compromises because you cannot possibly know what the original is like. Now, we chose not to go with this, but as you can see, this features vertical planks going straight into the ground, and that matches well with the original archaeology. Now, the problem is that the designers of this at Wessex Archaeology realised that you couldn't just put planks in the ground and expect the roof to stay up, because it would have that problem of being a house of cards. So hidden underneath these planks are a series of posts, big posts. Those posts are not indicated in the archaeology. So they've had to make a compromise as well. And that's what makes this building so interesting, is we can't figure out how to build it in exactly the way that the archaeology suggests. Now, something we have to say, of course, is the archaeology dates to between 3600 and 3800 BC. So it's pushing 5,500 to 6,000 years old. That means that there's most of what was there is gone. So there might have been slanting posts in the ground. There might have been a lot more post holes, but I don't think so. I think the archaeology is a real puzzle. What we've done, though, to, if you like, to say, okay, we don't know that what we've built is correct, we have put one wall with these vertical planks on. That wall, those vertical planks go into the ground, and that is sort of suggestive. It mirrors what the archaeology suggests, and it mirrors what Wessex Archaeology suggested. Along the side of the building, which you can't see here, we've also built some low horizontal walls. Those walls also go into the ground. So again, they mirror the archaeology of this earth, this basically organic material filling a big trench. We've done something similar at the rear wall. So we're trying to sort of give a nod to every possible expression of this building that we can. So what I would say is this building is very honest in saying we can't possibly know what the original building was like after all of this time. We've done our best to create an interpretation that is safe to walk in and reflects the scope of the building, the scope of the original building. The archaeology respects the archaeology, but it's very honest. We have to be honest, because it's very easy to come to Butser and think we've rebuilt the past. We haven't. We're building an experimental structure, an experimental model that not only tries to express the archaeology, but also tries to question, what is it? The problems we run into tell us as much as do the solutions we come up with. Now, what I've got up here is an interesting series of buildings. These are excavations from Ireland, and I'd like to just highlight a few of them here. These are all from the same sort of date. So you can see these are earth-filled rectangular trenches. This is probably a little bit light, but here is just our original archaeology sort of presented in graphic form, these two internal dividers. And here is one that is excavated in Dunsinane. So you can see again exactly the same form as the building that we constructed. This is slightly smaller, but what's happening at this particularly interesting point in time, all of these buildings date from about 3,600 to 3,800 BCE. In fact, there was one very recently featured on episode 2 of Digging for Britain. So if you haven't seen it, go back and have a look. And it's fascinating. They come out of nowhere and they go nowhere. All of the buildings before and most of the buildings after are much smaller. So it raises the question, if we're having so much trouble building this thing with a roof, we have to ask, did it have a roof? What sort of structure was it? Was it a domestic building at all? Now, it might be easy to say that, well, we failed really because we've had to cheat to get this building to stand up. Actually, that's a success. We've raised a lot of questions, and these questions are incredibly exciting, and it's something that we want to reach out to other people who have excavated these buildings and sort of go, look, these are the questions we've got. What do you think? So our building is great. It expresses the sort of scope of ambition of people in the early Neolithic in Britain and Ireland. So, but it's also raised some fascinating questions. So I regard it as an astonishing success. So we'll move on to our next building, which is a Bronze Age roundhouse. I've got a timer on myself, by the way, here, and so I'm planning that this goes for about 45 minutes, leaving plenty of time for questions. So we did this in conjunction with Operation Nightingale, which is a charity dedicated to the rehabilitation of service personnel, people often who've been traumatized or injured or otherwise affected by their service. And it's been a great project. So we've been able to sort of work from day one with Operation Nightingale in the way that we work very closely with Wessex Archaeology. And that's the ideal in experimental archaeology, is to work with the excavators, because you can cross-fertilize your ideas. Doesn't always happen, but that's the ideal. Now, the site we were excavating is on Salisbury Plain on military land. I'm hoping you can see this. This is actually a plan of a 1995 excavation, and this revealed a Bronze Age settlement. It had trackways, evidence of cart use, had evidence of agriculture, and a number of roundhouses. Salisbury Plain is one of the most astonishing repositories of archaeology in Britain, and it's preserved, ironically, because of the military. But they were building a new road here, and 50-ton tanks go over the top of this. So Richard Osgood, who is the head of Operation Nightingale and MOD archaeologist, wanted to do another excavation near this site to see what damage might have been done in the intervening sort of 25 years. So here we are on that site with one of the chaps, Chris, I think it is, with his arm down in a post hole. And that post hole, wonderful site, by the way, absolutely glorious. That's a group of our staff and Op Nightingale people. And that post hole is part of this structure. And this is the framework for a roundhouse. So each of these pink circles, or semicircular bits, is a post hole. In the middle, more or less, is another post hole. So that gives us a lot more structural engineering information already than we got from our Neolithic house. We're very familiar with roundhouses. We've built quite a lot of them. And those posts tell us that this building is being held up by a frame that's constructed around a series of vertical posts. And what we do, as we always do, is we take the measurements of that archaeology, and we use that as what is more or less the world's worst architectural plan. And what we do is we translate those, or transpose really those measurements onto our own site. And the great thing is our site at Butser is on the same chalk bed as the Salisbury Plain. So what that allows us to do, by not only do we translate the size of the thing, but we also translate the position of it. So it allows us to test the orientation of the building and to test the durability of the building. In building it, we were able to actually source a lot of our materials. Just We broke ground in early 2021 during COVID, but we were all able to distance, so it was great being able to work outside. We had a little bit of help. This fellow here was actually the one who broke ground for us, and you probably recognise him as being Phil Harding. So as we did with our Neolithic building, we used as much manual labour and simple tools as we possibly could. So things like antler picks, which is basically just a red deer antler with a sharpened end used as a pick. And we find them all through the Neolithic archaeology. You find them at the bottom of mines like Grimes Grave. You find them in huge hill fort ditches like Maiden Castle. So again, we're using very traditional materials and very traditional labour. That's one of our Bronze Age axes. That axe is actually a faithful reproduction of one that comes very nearby where we're located. It was found near Petersfield, and we have a wonderful bronzesmith called James Clift. We do workshops, by the way. If you want to come to Butser, we do bronze casting workshops, among a number of other things. So we were using the same sort of tools as we know that people in about 1250, 1200 BCE were using when this building was built. And you can see here, quite hard work. You can't swing them like a modern axe. They're more of a nibbling kind of axe. So it's very hard work with solid old oak timbers. So again, we used a lot of modern axes, but we proved our concept using the Bronze Age tools, which were the axes, chisels, and antler picks. These are some charred posts. They have a thing called a tusk tenon. So that sticky up thing nearer the bottom of the frame is what we're going to sit our horizontal timbers over. And the charred bases actually reduce the amount of rot that takes place when they're placed into the soil. The soil is the source of most of the damage to earth-fast timbers, which is why we don't make buildings with timbers shoved into the ground anymore. They don't last terribly well. You probably, in some cases, maybe 10 years, some cases maybe 20. So you can see, if I go back to the previous slide, there are our posts turned through 90 degrees, put vertically into the ground. So our vertical posts there, and we put some horizontal timbers, and they're sat over those sticky up bits, the tusk tenons. So that is the frame of our roundhouse. Very, very simple. Posts and lintel, you'd probably recognise it as being perhaps the world's worst model of Stonehenge, but it's the same technology as used at Stonehenge. So if you go back to our excavation, we turn this into this. So that's our frame fully constructed. It hopefully makes sense to you. You can see it's a very, very wide fisheye lens. A wonderful photographer, Harvey Mills, who works with Operation Nightingale, did. So there are our vertical timbers, all placed in the locations of our original post holes. And you can see this ring now of horizontal timbers. I hope you can see that. I love the photograph. I couldn't help myself but use it. Again, we use we use volunteer labour. Same again, simple building techniques, pegged and lashed. Now, I think it's very likely, and I think the evidence that we have, pardon me, from places like Must Farm support a more sophisticated approach to building than what we used. However, we take a minimalist model. We build what we know they could have built rather than speculating on what we think they might have built. I think in the future we'll move beyond that because we proved so much of what can be built, and with new evidence on timber working from places like Must Farm, I think we can move on to some even more sophisticated building techniques. But here you can see, looking up at the ground, that vertical post is what was represented in that post hole in the center of the building. And in this case, we've sort of tied this ring around and anchored all of our rafters against that vertical post. Now, this is actually unusual. Most round houses in the archaeology don't have central posts, but we had one, so we thought, well, let's see how it can be used. It's actually very useful for putting the building up. Makes it very quick to put it up. Whether it's needed for the structure is debatable, but it helped us. What we've also done with the building is tried a number of different wall types. This is a sod wall, and it's the sort of wall you actually get on barrows. If you've seen any Bronze Age barrows, if you cut through them, this is the technique they use to build up the bank on the barrow. So we thought it was very interesting that this house could be built a bit like a barrow. Some people have said that houses of the living imitate houses of the dead in prehistory. So that's just an interesting kind of suggestion of how these walls might have been built. What I should say is that one thing that was in complete absence in the excavation was the evidence for walls. We had the evidence for the frame in those sturdy posts coming from the post holes, but no walls. So what we've tried to do is build a series of ephemeral walls, walls that we expect in 3,500 years won't leave a trace. So that was our ambition. We build walls that keep out the weather, but don't leave much evidence. This one is a freestanding wall built only of crushed chalk. It is used like a very weak concrete. These other walls here, they're sitting beside our sod wall, but they're just banked soil. Now, you might say, well, this is going to actually leave a mound. It will look like a Bronze Age barrow in 3,000 years because there's a lot of earth there. And I think that's reasonable. But of course, it's worth saying that on this particular site, there's been ploughing. So any evidence for a wall may well have disappeared under the plough. And I could sort of talk at length about this, I won't, but these ideas of earth walls are actually very interesting. And we're sort of evaluating how long do they last, how comfortable they are. All of these walls, in fact, we evaluate all of these structures about how long do they last, how comfortable are they, how practical are they, how easy or hard are they to build. And also, one of the most interesting aspects of any experimental building is what happens when it falls down. What are we left with? Is the thing at the end, the evidence of the end, is that anything like what we started with? And if it is, that's great. If it's not, that's also informative. We may have to go back and revisit our understanding. And that is our finished product, which is a wonderful little, very eccentric house, but it's proving very comfortable. We had a gala opening. Alice Roberts there came along and buried a pot for us, which is a sort of new Bronze Age offering. And Operation Nightingale gets a lot of support from a lot of people. So in this slide we have the crew, but we also have Alice Roberts, we have Phil Harding, and we have Stuart also, who's part of the new Digging for Britain team, as well as the most important people who were the Operation Nightingale volunteers. It's a great charity, a great organisation, and there's a lot of backing, a lot of archaeologists who are really willing to help out. So I really think they're a wonderful organisation, absolute privilege to work with them. So moving on to the last house I want to talk about, we've actually got two Anglo-Saxon houses on our site. I should say I'm referring to all of these as houses, and round houses are so called. I should probably very succinctly point out that we don't ever know that they're houses. Sometimes there's a good clue. They might have a hearth and broken pottery and residue of food. That gives you a good clue that it's a house. But as with our Neolithic house we looked at, there's not really a lot of evidence to say it was necessarily a house. These Anglo-Saxon buildings probably were houses. But again, I want to point out that we never quite know with archaeology. This one is called A2 and was completed in 2014. Our second one, and that's the one that I want to talk about tonight really, although the two are tied together. The second one was completed in 2021, and it's called A1. archaeologists are nothing if not poetic in naming the structures that they find on their site. Now, these buildings, very excitingly, were excavated by Peter Addiman. Professor Peter Addiman was the gentleman who also excavated Jorvik, the very famous Viking settlement up at Coppergate in York, which subsequently kind of led into the Jorvik, I won't say theme park, but a sort of archaeological entertainment area that you might be familiar with, which kind of looks at Viking York. Peter was excavating here immediately before he took up that post. In fact, here, the site he excavated was done between 71 and 72. He left to go to York, and it was later taken over by Dr. Tim Champion, who was also a professor at Southampton University. Now, what's exciting to me about this is, the archaeology is really clear, and that's not often the case with Anglo-Saxon archaeology. And the reason for that is it's wood. So again, we've got a timber structure sitting in chalk. So what happens is the chalk's lovely and white. When the wood decays, it turns black. So this is wonderfully clear archaeology. But also, if you look over there, that's where Butser Ancient Farm is now. We weren't there then. We're actually further up the hill there, but that's where we are now. So the wonderful thing about this is that the structures that we have built, the only place on the site that you can see the excavation is from the doorways of our structures. This is an aerial view of the site. So you can see lots and lots of post holes here. I hope you can see them. So these are actually all structures. These are the evidence of structures and also things like fences. Those posts are pretty clear evidence of the structural engineering of these buildings. It's the sort of thing that would have helped us a very great deal in our Neolithic house, and it's a sort of puzzle about why they weren't there. Now, strangely, this looks a little bit like our Neolithic house, I suppose, but in these foundations here, so these black lines, or these dark lines that I'm outlining with my laser pointer, are actually the foundations of two houses, and they're two houses that we built. Now, this again is timber, so there was a lot of timber put into these trenches for reasons we don't completely understand. But within those trenches are also set post holes, and that's helped us a very great deal in building these buildings. Now, that's just an excavator's plan of the site. It was quite an extensive site. There were 61 buildings excavated there, 61 structures, as well as some fences and what looked like gardens, actually, that are attached to some of the buildings. And that's quite a big site. The site was there sometime between perhaps the early 7th century and the late 8th century. So it probably was there between 100 and 200 years. So in the Middle Saxon period, just at the point at which the Anglo-Saxons were turning to Christianity, which is interesting for other reasons, but I won't go into those this evening. Unless you ask me at the end, then I can go into them. This here is actually the excavator's plan of those two buildings that we looked at in the photograph. So here we have one foundation trench. Here we have another foundation trench. And we have built two buildings based on these side by side in a very similar orientation. And you can probably see these little circular sort of blobby bits that are drawn in there. They're the post holes. So what we're able to tell from the archaeology is that there are big trenches filled with timber and post holes set within those trenches as well. This is a fairly well-known Anglo-Saxon building type called a post-in trench for obvious reasons. Now, evidence. So what evidence can we use for our construction? Well, there is some Anglo-Saxon architecture surviving. Unlike Neolithic or Bronze Age buildings, they've long gone. We do have some Anglo-Saxon buildings surviving. And I just wanted to put these in because they're quite local. This one's at Corhampton. Doesn't help us a lot because it's made of stone, but it's a wonderful building, and I really recommend to drive down to Corhampton. It's one of the best preserved Anglo-Saxon churches I know of in Britain, and where else are you going to get them? and it's quite nearby in the Moon Valley. This one is Bosham. It's the Church of Bosham, which is famously associated with King Canute, but also with Harold Godwin, or later King Harold, or Earl Harold if you're a Normanist. This arcaded window is very typical of Anglo-Saxon stonework. Again, it's stone, doesn't help us a great deal with our timber building, but I threw it in because I just can't help myself. I love Anglo-Saxon architecture and archaeology. And this, I promise, is the last stone building. This is the Church of St. Lawrence, and yep, that is how it's spelled, by the way, in Bradford-on-Avon, which is the best preserved Anglo-Saxon church that I am aware of. And it's worth a trip to Bradford-on-Avon. Do visit the Tithe Barn when you go there as well. But this is a stunning church, which sadly was closed due to COVID when I was there. However, getting to something still ecclesiastical but more relevant, there is a small amount of surviving Anglo-Saxon timber architecture. And this is the best preserved, which is the Greenstead Church, Greenstead in Essex. And you can see along the front wall, those timbers date to around 1064. I think they've been chronologically dated to the 1060s. Unfortunately, they've been sort of cut up a little bit. They haven't been moved, but that brick plinth has been put underneath them. What they originally were a palisade-built church. So the church originally was all timber. You can get up close to them, and you can see the way that they've been worked using axes. There are little fillets of timber put in there. So if you pull the church apart, you can get some understanding of Anglo-Saxon woodworking. And also there is an Anglo-Saxon door in Westminster Cathedral that's been recently evaluated in a wonderful paper by a couple of guys who have come up with a reinterpretation of Anglo-Saxon building techniques. Previously, that was thought that they were used fairly simple jointing, fairly rudimentary carpentry, and it wasn't until the Normans that we got these more elaborate joinery techniques. They've demonstrated that actually, certainly by the 11th century, the Anglo-Saxons had very good timber working. So all of those little things we can feed into our building. Another thing we know is from other excavation. This is very interesting. You may recognise it. This is from Cowdrey's Down, which is in Basingstoke or near Basingstoke. So you can see these little hatched lines there. What they represent is the end of timbers that have been put into the ground, and it's called a hit and miss boarding technique. So what they do is they overlap these timbers, and that keeps the drafts out. So instead of having to use weatherboards, they just overlap timbers, one stacked on top of the other, and that's a good draft excluder. Now, that isn't structural. These holes out here are actually large things that are called raking posts. They're effectively buttresses. But again, we can use that evidence for knowing how the Anglo-Saxons used timber. And I throw it in there also because I thought it was of relevance to your good selves. So going back again to our archaeology, this is our rubbish architect's plan. Great archaeologist plan, rubbish architect's plan. Happily, they've also done a section. So you can see, turn through 90 degrees, these are the sections, these are the side views, cutaways in the trenches. So you can see post holes within trenches. And all of this is organic material, so all timber. Some presumably set horizontally, the posts, of course, set vertically. This is my drawing of how we've interpreted that. So here's our ground, and here are our vertical posts set into the ground as our structural timbers. So if I go back, we have to allow for years of degradation and ploughing, but you can see this sort of sawtooth profile here. That's how we've interpreted what was going on in that profile. Here we have horizontal timbers. They're also set into the ground. So the combination of those vertical and horizontal timbers over the next 1,400 years will hopefully decay to give future archaeologists a profile like that, a section like that. So those are the sort of background information to the way that we came up with this. Structural posts are within this building, our vertical posts. On the outside, we've used this hit and miss board. Now, hit and miss is a wonderful carpenter's term. It means that, you know, you don't join up all the boards, you just keep overlapping, one out, one in, one out, one in. That's a wonderful term. Not structural, but we know from Cowdrey's down the Anglo-Saxons used it. We've done all of our structural work below ground so that it's our best possible interpretation of what the original archaeology was telling us. And that's what we've come up with. Now, again, we've assumed a thatched roof. We don't know that for certain, but there are good reasons to think the Anglo-Saxons, well, actually, we do know the Anglo-Saxons used thatched roofs because it's mentioned in Bede. So that tells us the Anglo-Saxons used that material on the roof. It also then tells us that the roof pitch is probably about 45 degrees. So there's historical evidence in this case that we can draw upon. And all of these things fill in our jigsaw. Inside, we've got a roof truss. So this roof is beautifully built. It's actually built by a wonderful tree wright, which is actually an Anglo-Saxon term for a carpenter, really, or a builder. And he's used beautiful dovetail joints in here. Now, dovetail jointing is a wonderful joint. You'll find them in drawers, for example, in well-made carpentry, in drawers. They're very structurally sound. We don't know that the Anglo-Saxons used them in buildings, timber buildings, because they don't survive, but they're extraordinarily good for building roofs because a dovetail joint is able to resist forces in 3 dimensions. So we don't have our house of cards that I mentioned earlier in our Neolithic house. Now, we could have built a building like this. In fact, our Neolithic building is bigger than these buildings, but we could have used this sort of jointing, but it's only known from about 1300. We only have about direct evidence for this type of jointing from about 1300 AD. So we've got a gap there of 4,500 years. So we can't, you know, we didn't want to fudge that much. In the Anglo-Saxon building, there is enough evidence to suggest that they may have used this type of jointing. In fact, there's some really interesting evidence. This building isn't built with nails or screws or fasteners. It's built with things called tree nails. And tree nails, you might be able to make out some little ends here and here. Tree nails are also called trunnels, and they are what the name suggests. We would call them dowels, but effectively they are large dowels. They're put through corresponding holes. So if we want to join our angled rafters to our horizontal tie beam, as it's called, tying our roof together, we drill corresponding holes and we put our tree nails through them. But to finish them off, to make sure that they don't move, the end of the tree nail is split. So an axe is used to split the end of the tree nail when it's in position, and a little wedge is hammered in there that expands the tree nail, and that then really tightens the joint. And what's really nice about this is that if you look at preserved timber work on Viking boats, you will find the evidence for exactly this type of fastening being used in Viking boat building. So this is Anglo-Saxon, they're Vikings, but the sort of technology they were using and the cultural ties allow us to go, okay, we know that the Anglo-Saxons used tree nails because the term trunnel or tree nail is an Old English or Anglo-Saxon term. So there's, again, archaeological evidence to say this is a very reasonable interpretation of how this building might have been built. Really, here endeth the presentation. I want to say again, thank you very much for your forbearance, for inviting me, and yeah, for allowing me to sort of extol the virtues of Butser Ancient Farm and experimental archaeology. That's me with one of my archaeological heroes. That's Professor Peter Addyman. So I was delighted to be able to do that. Thank you very much. Any questions? I'm happy to talk.